All right, so people have asked me to kind of go over some highlights from 10.3 to help them out, or if they're going to take a retest or something else. So let's kind of talk about 10.3 a little bit. So in 10.3, we were still looking at rational expressions, but we were going to start multiplying or dividing or simplifying or whatever we needed to do with them. So there's a couple key things. One, whenever we're dealing with rational expressions, our first job is to factor everything. So gotta factor everything. It's gonna make life much easier. Second, we're gonna check the denominators. For any values, they'll make those denominators equal to 0. Those are gonna be discontinuities or restrictions on the domains, or just things that the letters cannot be. So we're gonna check that the denominators are equal to 0 and use those to find any restrictions. We'll perform whatever the operation is. So today we'll be looking at simplifying, multiplying, or dividing. Once we're done, we'll simplify whatever we get. And that's kind of what we're going to go for here. So let's take a look at a couple examples. We'll go through this a little bit quick because I know you guys can pause the video as you need to. So let's take a look, and we want to examine something like x squared plus 7x plus 10 over x squared minus 3x minus 10. So we don't have any other directions. We're not multiplying, we're not dividing. So instead, we're actually just going to simplify this. So our first step is to actually factor it. This is a trinomial, it's factorable. This is x plus 5 times x plus 2. On the bottom, we have x minus 5, x plus 2. So after we do our initial factoring, now we're going to check, say, okay, what can make this denominator equal to 0? So if I look at that basic thing right there, we have our x minus 5 times our x plus 2 equals 0. And that would yield two things that are going to mess this up, x equal 5 or x equal negative 2. So these are what we would have called in 10.2 our discontinuities. In this one, they're just going to be restrictions. They're things that mess up our variables when we're doing these operations. Now that we've done that, we're going to go ahead and perform the operation. In this case, there's no multiplying or dividing or anything else. So we're just going to simplify. We have matching factors, top and bottom, that can cancel. So those would cancel out. And my answer would simply be x plus 5 over x minus 5, with the caveat that x cannot be negative 2 or 5. Because those are the values that would make the denominator equal to 0. So this is what we're basically looking at as we're trying to factor things. So let's take a look at another example of simply simplifying. So how about x squared plus 2x minus 8 over x squared minus 5x plus 6. So we're going to start with the same thing. Our first step is to factor everything. This is factorable. It's a standard trinomial. So we have x plus 4, x minus 2. On the bottom down here, we have, let's see, x minus 3, x minus 2, as we factor them out. We take our denominator, we set them equal to 0. So we have x minus 3 equals 0. We have x minus 2 equals 0. So we have two values, x equals 3 and x equals 2 are values that would mess this up. We perform the indicated operation, nothing to do with it this time. So now we can simply simplify. We have an x minus 2 top and bottom. So I get x plus 4 over x minus 3, but x cannot be equal to 2 or 3. So that's kind of our basic idea behind simplifying. So let's take a look at an example of multiplying as our next little operation that we'll do. So let's try something like this. So 3x over 35y times 49y over 12z. So here we actually have an operation. Now our first step is to factor everything. All right, well, these are monomials. So it's a single term, single term, single term, single term. No factoring to be had. So our next step is to check all the denominators and set them equal to 0. So I have 35y equals 0, so y equals 0. And I have 12z equals 0, so z equals 0. So we have two values that are going to be restrictions on our domain. Now, since we're multiplying it, we can actually just multiply right across. So that would be like 3x times 49y over 35y times 12z. And honestly, this step is kind of optional for you. Some people find it easier to see it that way. Other people like canceling straight from here. It doesn't much matter. We performed the operation, we multiplied. Now it's a matter of canceling everything we can top and bottom. So I got a y on top, y on bottom, so those cancel out. 3 can cancel with the 12, leaving a 4 behind. 35 and 49, 7 goes into both of those. And that looks about what I could do with it. So after we do that, it looks like we'd have a 7x on top. On bottom, we'd have a 5 times 4 is a 20z. So our answer would be 7x divided by 20z. But y cannot be 0, and z cannot be 0. So that would be my answer. So again, factor everything. Set the denominator equal to 0 to find out what the restrictions on your domain will be. Perform the operation and simplify. That's kind of what we're looking for here. So let's take a look at another one. How about x minus 2 over 5x times 10x over 3x squared minus 12. So again, we're taking two rational expressions and we are multiplying them. First step is to factor everything. So in this case, well, x minus 2, that doesn't factor. 5x, that doesn't factor. 10x, that doesn't factor. 3x minus 12 does factor. We could factor out 3 from it. That'd leave us with x squared minus 4. And x squared minus 4 is a difference of squares from algebra 1. So this would be 3x plus 2, x minus 2. All right, so we did that. Next step, we check the denominator, set them equal to 0. So I have 5x equals 0. And I have 3 times x plus 2, x minus 2 equals 0. So now I can take each of these and find out what values. So that'd give me x equals 0, x equals negative 2, x equals 2. So now we have 3 values that can actually break this. Now that we've gone ahead and identified the restrictions on our domains or restrictions on our variables, we can go ahead and actually start canceling. So I've got an x minus 2 on top and an x minus 2 on the bottom. They cancel out nicely. Let's see, I've got an x on top. It cancels out with an x on the bottom. 5 there can cancel out with a 10, leaving a 2 behind. And it looks like all I end up having left is a 2 on top and 3 times x plus 2 on the bottom. So that's my simplified answer. And now we're going to include any restrictions on the domain. So x cannot be equal to negative 2, 0, or 2. So again, as we approach these, it's the same kind of steps. Factor everything first. After you're done factoring, take the denominator, set them equal to 0 to find any restrictions on your variables. Once we've done that, go ahead and multiply by putting the things together, and then cancel top and bottom. List out your answer with the restrictions on domains. So we'll do one more multiplying problem, and then I think we'll talk about division. So let's try this one. X squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3. All right, so first step, factor everything. So on top, it's a standard trinomial, and we'd have x plus 3, x minus 2. On the bottom, nothing we can do with it. It's just x minus 5. On top, that's a difference of squares from algebra 1, so that's x plus 5, x minus 5. On the bottom, this is a standard trinomial, so that's going to be an x plus 3, x plus 1. All right, so we factored everything. Next step, take the denominator, set them equal to 0. So I have x minus 5 equals 0, and I have x plus 3, x plus 1 equals 0. That gives me x equals 5, x equals negative 3, x equals negative 1 as our values that cannot be. These are the restrictions to our variables. Now that we've done that, I can go ahead and combine them. So with multiplying, we're just smushing it together so I can start canceling top and bottom. So let's see, we've got an x plus 3 that cancels out with an x plus 3. I've got an x minus 5 that cancels out with an x minus 5. And that looks like it. So we'd have an x minus 2 x plus 5 on top. On the bottom, we just have x plus 1. So that's my simplified answer. And then we include our restrictions. X cannot be equal to -3, -1, or a +5. All right, so that's our basic process for multiplying rational expressions. Let's take a look at division. Division is almost identical. We are basically going through the same steps. There's just one little extra step we need to do. So let's do one simple one and then one longer one, and then that'll be it. Bring us to the end of this little mini review session. So in division, let's take two rational expressions and divide them. Now, when we divided fractions way back when, back in elementary school, say something like this, in order to divide fractions, you had to flip the second one upside down. So that became 2/3 times 5/4. And then we could just multiply straight across like we normally do. We could reduce it and we'd get 5/6. So this is still kind of what we're going to do here now. So our steps are almost identical to what we did before. First step is still factor everything. All right, monomial, 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 monomial. We can't factor anything, done. Second step, we take our denominators and set them equal to 0. So we have 4y equals 0. I have 5z equals 0, so that gives me y equals 0, and z equals 0. Now, where division changes for us here is when we get to go to the actual operation. So to divide, we're actually going to have to flip this upside down. So that becomes 3x over 4y times 5z over 6x. So I'm actually reciprocating that second fraction and making it a multiplication. But if we've done that, now we have a new denominator. So we need to check that and make sure that can't be equal to 0. So I'm going to add it to my little list of denominators. So we've actually gotten a third restriction on our domain. Now that we've done that, and now that we're multiplying, we can just cancel top and bottom like normal. So x can cancel with x. Let's see, 3 can cancel with the 6, leaving a 2 behind. And it looks like I'd be left with 5z over 8y. With all of these restrictions, y cannot be 0, z cannot be 0, and x cannot be 0. So we have almost the identical steps. The difference being that when we flip that second fraction upside down, we still need to check that denominator and state that it cannot be equal to 0. So it gives us one extra check that we need to do. So let's do one more of these so we can get a little bit more practice in. I'll do kind of a large one, and then we'll go from there. So let's take a look at 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. All right, a lot going on in this time. So first step is to factor everything. Now you'll notice that this term up here is the 2 minus x. That's not one that doesn't play well with others. We usually like to write them as x plus or minus something. So one easy trick from Algebra 1 is we can actually factor a negative out of that. So that'd become -1 times x minus 2. If we distribute it, negative x, yep, positive 2, it still works. On the bottom, this is a perfect square trinomial, so that's x plus 1, x plus 1. All right, we'll factor the top over here. So -10, still giving us a 3, so that's going to be an x plus 5, x minus 2. Now on the bottom, this is a difference of squares from Algebra 1, so that's x plus 1, x minus 1. Okay, so we factored everything. We're going to take our denominator, set them equal to 0. So I have x plus 1 times x plus 1 equals 0. I have x plus 1 times x minus 1 equals 0. So that gives me x equals -1, x equals -1, x equals +1. Okay, now we're ready to perform the operation. To multiply, we need to flip that second one upside down. So that's -1 times x minus 2 over our x plus 1, x plus 1, times, and we flip that second fraction upside down. Now that it's upside down, we have a whole new denominator, so I need to go and I check that as well. So that's x plus 5 times x minus 2, and that can't be 0 either, giving us more restrictions. X can't be -5, X can't be 2. Okay, so now we've listed our restrictions. We're ready to multiply so we can cancel top and bottom. Looks like we got an x minus 2 and an x minus 2 top and bottom. We got an x plus 1 and an x plus 1. And that looks like it. I don't see anything else that cancels. So we end up with negative 1 times x minus 1 over x plus 1, x plus 5, with a whole bunch of restrictions. X cannot be negative 5, negative 1, 1, or 2 for all of our restrictions. Okay, so that basically formed what we did in 10.3 when we talked about 10.3 in class. We are looking at multiplying and dividing rational expressions, canceling top and bottom. So your general steps were 1, factor everything. 2, set the denominators equal to 0 and solve them to find the restrictions. 3, do the operation, actually multiply them together or divide. In the case of division, you'll then get a new denominator. You need to set equal to 0. And then 4, finally, we kind of cancel everything out and we state our answer, including using the restriction on domain.